You're all.
Alright. Do you ever feel overworked? Like there's a constant backlog of stuff that you need to do? Well, that's an issue currently in the biology research community, and what our solution is built around fixing. My name is John King. This is Nicholas Peretti, Ian Montgomery, and Austin Hartnett. And for the last 2 semesters, we've been working on Phoenix Bioinformatics Interactive Literature Curation Portal. Our sponsors in Phoenix Bioinformatics are Tanya Berardini, Eleanor Reiser, and Trilok Prithvi. And our coach is Bruce Herring. So today in our presentation, we'll go over an overview of what our project is. We'll go through the workflow that the average user will use in the website. We'll go over the design and architecture we use to build the website. We'll do a demonstration of the current functionality in the website. We'll go over the challenges that we face as a team, our successes and our mistakes, and the lessons that we learned, and then we'll finish up with the future plans of the website. So, currently in the biology research community, a researcher will create a research paper and get it published, and the information inside of the paper is in a free text format. Then a curator, after this paper is published, will go through this paper and take out the information in there and turn that free text format into a formatted annotation. This is done because this formatted annotation can easily be stored and searched and later retrieved, whereas if it was kept in a research paper, it might be harder for other researchers to get the information for their own work. The problem is there's a lot of papers coming in, but that the curators can't all get to, and there's always a backlog of things. So the goal of this project was to create an easy-to-use website that would allow the researchers to create their own annotations from their papers, and then the curators would be able to quickly go through and just check the submitted information for accuracy. So that means that there are 2 users for this website, 2 main users. There are the researchers who will be creating or submitting the information from the papers, and there'll be the curators who need to access those submissions and either approve or reject them. In order to accomplish this, the website needs to have a very user-friendly interface so that it's as open as possible to researchers to go in and enter the information. To help along with this, the data entry form that we use for the submissions changes as the information is entered because there are different kinds of annotations that all require different kinds of information to be entered. So as the researcher is entering the information, it'll kind of guide them along in what needs to be entered. It also validates this information as it's entered to make sure that all of the required information is met. And then once the curator checks that submission and approves it, that approved annotation needs to be easily accessible by other researchers so that they can pull it out and use it for their own research. So we'll go through the workflow that the average user will have in the website. So after a research paper is published, the researcher who wrote it can log into the website using an ORCID ID. ORCID is a third-party authorization system that's used by a lot of different research communities, so a lot of them will probably already have an account with it. Then they'll go into the submission section of the website and enter in their paper's ID information, so that could be something like a DOI number, and then they'll start pulling out the information from that and entering it into the data entry form. Once all the information that they have in the paper is out, they can do a final review on the next screen before sending it off to a curator to check. Once a curator receives these annotations, this submission, they can start checking it for errors. So they'll have access to the research paper because of the ID that the researcher sent in. They can go and look up the paper themselves. Then they can compare the information to what's in the paper to make sure it's all correct. If the annotations appear correct, they can approve them one by one. If there's a minor issue with the annotation, they can edit it before then approving it. Or if the annotation is just completely wrong, they can reject it, and then that won't be stored in the database. So once there are approved annotations stored, this needs to be accessed by the researcher. So there's an export file that is created once daily around midnight Eastern time. Any user that is logged in or logged out has access to downloading this file. We want this information to be publicly available because it's going to be used for research purposes. So it shouldn't be blocked behind having an account or not. And the export file, the information inside of it, is conformed to industry standards to make it as easy to use as possible for anyone who wants to access that information.
All right, I'm going to go over the overall architecture. So kind of going from the outside in, we have these third-party resources that have information that we need, such as the publications or information on the genes. And what we do is we actually go to those third parties and we cache a lot of this information. So what genes are valid or publications, and we save them in a Postgres database. So our backend, which is the Node and Express backend, can really quickly access that information without having to reach out whenever the front end, which is an Angular front end, needs to validate, for example, a gene. It can quickly ask the backend, is this gene valid? And it'll know right away. And we run that caching, I think, well, right now we run it manually, but ideally we run it in a cron job or something, because it does change periodically when new information is collected. All right.
Okay. So I'll be giving a quick demo and a little bit of heads up before the demo. So I'm going to be creating an annotation. I'm going to be creating an annotation. This is the title, the genes, and then the actual annotation are two types of things. Now, this paper is actually just going to be accessed by a publication ID. The genes are going to be accessed actually by another string unique identifier. Then the annotations are kind of the meat where then you enter the information. But all of this is going to be validated through our system to make sure all of it's correct. Huh?
I got it, sorry.
Huh?
Come on, play. Try present clicking. Oh no, very good space.
One second. So what you're going to see in about a second is
Is if we do it working. Yeah.
can you get it?
I have no idea. Like right click on it and see like play it.
No.
I have no idea what's on.
Oh, there we go. Okay.
There we go. Perfect.
Okay, so sorry about that. So here you see that publication. I've already entered a lot of the information because it's tedious to watch me type it. So you enter the publication ID, the unique gene identifiers, and type in the symbols. And then the meat of our thing is this annotation here. So here I've already entered one of those annotations I talked about, but we're going to enter another one. So if you see a Go process and a Go function are actually two different things. And biologists will know more about what these mean. But if you want to say, show us that same information, a taxis is not actually associated to a function and therefore won't be available. So this thing that you can search on is all auto-populated from those things we talked about. And then we have multiple types of annotations and they all have different forms. So there's protein, but we're actually going to do a PO, which you choose a location, and then a method that's how that was proven in your the paper they're annotating. So then you submit your annotation, and you created your two annotations, and you send them to a curator to look at. Now this is typically where another user or curator would come in and go to the curation page. Usually it's not the same person. So here you can see all the in-progress ones and ones that need review. So on the top there is the most recent one. We're going to review it. And you'll see a very similar screen, but with the exception that these two annotations you can now approve or deny. So saying you would read the research paper and agree with these points or disagree. Then you can save, and these are now accepted and are put into our database. And now you can search on them, and the export data in the morning will contain it. So if we want to search for just my name, you actually see all of the things that I've had in creating. And then we actually have this feature where you can then export all of the things that you searched. So you can also search on things like publication IDs and gene types, and then export all the things that include that gene. And then that's going to be exported into that file format that we talked about earlier. That's the standard for the industry. It's not too exciting, but it's just a text file containing all the information. And on the bottom there is the most recent one that I put in.
And I'm going to talk about some of the challenges, even besides not getting our demo working. So we're the third year senior project working on this system. So when we inherited it, we kind of inherited it in sort of like a broken state. A lot of the major features weren't working, like the curation thing that was just demoed. That feature did not work. It wasn't functional when we inherited the system. And their documentation for it it explained how to kind of get things installed and running, but it didn't really kind of explain their sort of architecture or how everything worked or why it worked or how it worked, and that kind of made sort of things hard to reverse engineer. And another thing that a challenge that we had to kind of get over while doing this project is, as you can see, because of the demo, there are a lot of different kind of edge cases to this sort of system. A lot of annotations need specific information and others do not. And kind of getting a handle on testing all of those edge cases proven to be a little difficult for the team. So now we'll kind of talk about what went well during this project. We did an entire front-end rework. The original system when we inherited was a React Redux-based sort of system, and we switched it to Angular. This fixed that initial curation bug that we were running into, and so it all worked properly. And it kind of helped us switching to an Angular system because it's something that we all had we were all a little more familiar with, and it kind of helped us kind of understand the code a little bit better. And we also added the search feature that was in the demo. That was a feature that was requested by the sponsors and something that the second team couldn't get to, but we kind of picked it up and kind of got a search feature running. And some sort of kind of learning points that we kind of learned during the project. One thing is that we didn't really kind of take full well of what our tech stack was working. Constantly during the kind of between the front end and back end, when you'd get an object returned, it would have it'd be the same object, but it had different names, so there wasn't really kind of a way that we could kind of fix that. And in a lot of the database tables, they had kind of dual things. A lot of those tables could have been merged and kind of made things a lot more simpler and easier. And kind of what we did was we tried at the beginning of the project, we kind of tried to learn React Redux and to try to reverse engineer kind of how the front end works and how it kind of interfaces with the back end. But we kind of found that the front end didn't really behave the way it was supposed to. There were a lot of, once you try to fix something, another bug totally unrelated would come up. And so our solution was to kind of, redo the entire front end in Angular, and we kind of underestimated the time it would take to kind of fix that sort of issue.
I'll go over a few of the lessons learned that we had over the last 2 semesters. So an important one that we had is really define your front-end testing strategy early on. We had a good testing strategy at the back end with unit tests over all of our features, but we didn't really have anything set up for the front end. So as we mentioned in the challenges, there are a lot of edge cases to this project, and we weren't aware of all of them at the beginning because we didn't really know what to check for because we hadn't defined this. And we realized kind of like about a few weeks into the semester that this was a real issue. So we kind of took a left turn, or we decided to sit down and redefine our testing strategy. We talked to the sponsors about what all the different use cases are. And for instance, one of the steps we took to fix this was on the GitHub wiki for the project. We created a bunch of pages that have different steps that users could take to go through to try and show all those different edge cases, so that while we are testing and while any future teams are testing, they'll know what to look for and not be missing those. All right, another lesson that we learned was to start working on your server environment and your server automation early on. Initially, we didn't start right off with that. We kind of started off with code, but then what ended up happening was the deployment servers would sometimes have outdated versions of code, or they wouldn't be available, and at times this blocked our development as we were going along. And it took a while for us to end up getting those to a more robust state where they were more automated and they wouldn't crash as often. And once that we had that smoother pipeline, it really starts helping us speed up our development. And so now we'll finish up with the future plans that Phoenix Bioinformatics has for this project. So they told us that from here, one of their teams is going to pick up this project. They're going to add in new export formats as are defined by the community. I believe there's a conference happening soon for a whole new, to change type of format. They're going to add in new data fields to the submission form to kind of widen the range of information that can be entered by a researcher. And any other new features they have, they're going to begin work on. All right, thank you. Does anyone have any questions?
If you were to start this project over, would you still swap out the front end completely?
If we were to start this project over, I think, I mean, you kind of looked into it the most, but.
Yeah, I think, so Node and Express are pretty good, but like, I would have maybe used a more powerful backend framework. The React Redux Angular thing was largely a, like, there's nothing really against the React Redux thing. It's just that when we inherited it, it was so beefy, like the reducer for the Redux store was really, really hard to mess with in a way that didn't break it. Like it was just, obviously it was one big one, and it was just one guy on the last team that made the whole thing. So without like picking his brain, we couldn't really fix it without breaking something somewhere else. So honestly, like if I were to start again, I'd just pick a beefier backend framework and either Angular or Redux from the beginning, or React Redux from the beginning. I don't super have a preference. The biggest reason we switched was it was really hard to touch the old one, if that makes sense. Does that answer your question?
I want to piggyback on that.
Yeah.
So perhaps there is in the next team, or perhaps
Yeah.
another senior project won't end up with your code base. But what would you say are the assurances that you have now in having taken this step, presumably because you feel more comfortable, that some other team is not going to say, well, we're going to move it to React, because,
Yeah.
we know how to do it.
So, okay, so one of the unfortunate things we realized towards the end is the nature of the problem, like with that really dynamic form, is it is very coupled. Like the problem, like every piece of the form depends on another piece of the form. So the more you split it up, the more connections there are going to be with those individual parts of the form. And one thing we tried to do to make that very clear, like even though it's hard to do it very concisely in our Angular code, we use services that tend to do a good job of making it like very reusable, so that, like for example, when you see the curation page and the submission page, it's almost like basically it's MVC versus Flux, right? So our M in the front end is the services that get the information, and we did a really good job, in my opinion, of splitting up that from the actual view. Whereas it was in the React Redux, it was really tied together with React.
We have also been adding a lot of information to the wiki, like I mentioned, with like the front-end testing to try and explain how our code works as well as how to get it set up.
So hopefully that the next team who picks it up doesn't really run into the problem that we had, where they kind of explained how it works and how to get it set up, but they really didn't kind of dive in deep and explain why they made the design choices that they did.
Does that answer your question?
Cool. Any other questions?
All right, that's time for things.
It's yours.
Hello, we are the TOPS team and we worked on the TOPS product locator. I'm Melissa, this is Laura, Ian, and Sultan, and today we're going to talk to you about our senior project. Before we start, we want to talk about some of the people not up here, but our sponsors. We worked with TOPS, the supermarket I'm sure you all know and love, and we worked with their technological partner, DXC, who works with a lot of their technological tools, and we really worked with Peter and Sukesh from there, and they were at every meeting helping us along the way. So today we're going to go over the problem the sponsor gave us, how we designed, implemented, and tested this product. We're going to showcase to you our working demo, and then we're going to go into some future work and also some challenges we faced along the way, along with some of the lessons we learned and positive feedback from the project. So to start off, who hates long trips to the supermarket? You get lost, you go down aisle after aisle, where is that one item? It's so frustrating at times. And TOPS, the super customer-focused grocery store, wanted to solve this problem. They wanted to see how could we help customers going through their shopping experience, make it faster but also easier. So TOPS tasked us with taking their planogram of data and having us design a tool that could have users searching for products and we could give them an exact aisle number of where that product is currently located. So what we focused on is 3 iterations of first creating a minimal viable product and then going into some updates with how we did our searching and integrating Google Maps API. And then at the end, we did a whole database redesign and added on some features for our web, tablet, and mobile accessible product searching tool. And now Sultan's going to talk to you about some of our technologies.
So for the main language that we use to build the web application, we use Python, mainly because most of the team members already know Python. So we thought that would give us a really good head start and lower the overhead of learning a new framework. Also, Flask is really easy to work with and it's properly documented. There's a lot of community support for it as well. For the database, we used MySQL because the database that the sponsor gave us was an Oracle, and us being students, we couldn't get an Oracle license. So we just converted that database into MySQL so we're able to work with it. For the front end, we used HTML, CSS, and JavaScript. For the version control, we utilized Git and GitHub. And for location detection, we used the Google Maps API, mainly because it was the most accessible API that we found for location detection. Also, it had pretty good results compared to some other options that we looked into. Moving on to the architecture, this shows the architecture of the website once it's been deployed. As you can see in the far right of the diagram, we have the MySQL database that updates its data every week or so, I believe, from the Oracle database that TOPS maintains. From there, we have the database interface that is the only module in the whole application that is able to talk to the database itself. We also have after that we have the templates that are dynamically populated and generated with data. And now Laura's going to talk about the implementation of the web application.
So in this part, we're going to kind of focus on the key main features and applications that we focused on during the duration of this project. We kind of teased at it a couple times. A really big thing this semester in particular was database restructuring. During the life course of this project, we probably iterated over the database probably about 3 or 4 different times. Initially, TOPS has a 5-table structure that they use for their database, and the first semester we really focused on just parodying that to our application and ensuring that we had the basic logic working. After that, we had some issues with performance that some of you might remember from last time, and so we then decided to try to shift those 5 tables into 2 or 3 kind of key tables. That still really wasn't giving us the numbers that we wanted. So we received the design from TOPS and DXC that was one singular composite table of only the information that we needed for this application. You guys can see the design of the table up there. It's everything that we need and this application needs to run. We have all the information about the product, from its name and ID number to its category and manufacturer, things you might need for searching, and information about the store that it's located in, such as their actual aisle location in that store, the store number, the store ID, everything that we need, one-stop shop. Ideally, this database would be updated maybe once or twice a week whenever products end up getting cycled through, and this data would persist in our one table. But unfortunately, because we decided on the database design so late this semester, it led to pretty much a logic refactor of our entire application. Luckily, we were able to salvage a lot of the code we wrote last time because we just used that to populate the one table. Instead of putting that result on the app, we just put it in the table. And the rewrite part of our actual application logic was pretty simple because we only had one table to interact with now instead of 5. And after we did this, we had to test to ensure we had complete feature parity. We wanted to make sure that all the responses that the users were getting were the same, regardless of whether it was the old process or the new process. Another big kind of aspect of what we focus on in this implementation is our overall UI features. We really wanted to focus on simplicity. List the product name, the aisle name, what your search is, and that's it. We didn't want to confuse the user. We wanted to make it as clear as possible that what they're searching is what they're getting. We also added a load more results page, so if the first 10 results are not necessarily what the user is looking for, they can hit load more, and they can keep searching until they find what they were looking for ideally. We also wanted to make sure that we matched the TOPS color scheme from their web and mobile applications. It's really pretty red, and we had to extend that into this application. Another big feature that we focused on that Sultan's going to go a little bit more into now is the way that the store selection process works. We can either do it automatically through the Google Maps API, like we mentioned, if you approve your location, or if you don't, you can manually select your store by searching by city name.
So some of the big things in the location detection feature is that it prompts the user when they open the website or the web application for the very first time to allow or disallow them to use the web app to use their location. And that decision is safe. If they want to be prompted again, then they would have to interact with the browser itself because we're using JavaScript to make that prompt and not the backend itself. The Google Maps API only gives us the store number. It looks for the nearest stops within 100 meters of the current location of the user, had they allowed their location to be detected. So we used a Python library that checks the similarity between the address that Google Maps gave us and the list of addresses for top stores that we have. And we use that similarity to know which top store exactly is near the user currently. And now, just to talk a little bit about the testing. So since performance was a really big priority for our sponsor and for us as well, we focus heavily on performance, especially for searching results and for location detection as well. In iteration 1, we had a lot of issues with performance. The average time was about 8 to 10 seconds sometimes, depends on the item that you were searching for and which store you were searching in. But we're really happy with the numbers we have for iteration 3, where it's usually less than 1 second, regardless of the other factors like which store or which item. For location detection, we did not have a benchmark to compare that against because we did not have that feature in iteration 1. So for iteration 3, we're pretty happy with between half and 1 second usually, which is pretty good. It also depends on other factors such as the user's connection itself and other stuff. So for acceptance testing, we focus on 3 main use cases. First is that the user searches for a valid product or category or brand, and they get the associated results, the correct results from that. The second one is that the user opts to have their location detected. If that happens, the app then should continue and should not prompt the user to select their store because the Google Maps API should already handle that. The third one is that the user selects not to have their location detected, and then we should have to walk through a flow of the user typing in their city name and have dynamically populated stores based on the text that they're entering. For unit test, we're happy that we maintain our average of 85% of unit tests for the backend. We're not doing many unit tests for the front end. For compatibility testing, there are so many platforms that we support just because the TOPS user base can be really broad, so we want to make sure that we cover all of our bases. So for Mac and for Mac OS and Windows OS, we support pretty much the same browsers with the exception of Safari being for Mac OS and Microsoft Edge for Microsoft Windows. For the mobile and tablet devices, we support both iOS and Android with Safari in iOS and Internet browser in Android. Now Melissa's going to walk you through the demo.
Thank you. Okay, so now we're going to get to showcase our working product. This is going to be really fun. I want you all to imagine you're at the TOPS DXC household and we're getting ready for taco night. It's really exciting. We're all pumped for it, I can see. But we realize we forgot a few items and we have to go run to our favorite grocery store to pick them up. What do? You grab your phone, you grab your keys, and you get straight to the grocery store. So what I'm going to do off screen, I'm clicking accepting to the Google location API, so it immediately gets me to my current location at my tops, and I can just immediately start looking for items in their database. It's really easy to just search an item and then go back and search for more. You can really clearly see the aisle numbers and not get bogged down by certain other features. And when you go for, let's say we're going for salsa, you know, Tops carries a lot of salsas, so we can load even more more products of salsa onto the screen till you find the last paste chunky salsa, perfect. We found every item we need. We can get back for taco night just in time. Woo! This is so great, so users can have such a fast experience. They also could access this on a computer where they could plan and strategize their shopping experience ahead of time. So this is a really great tool that it can integrate into so many Tops technologies. Oh, whoops, sorry. And now Laura's going to talk about some of the reflections of the project.
Great. So in this section, we're going to talk a little bit kind of about things that we wish we were doing, things that Tops and DXC are currently working on, and we're going to kind of look back on some of the challenges that we faced and what we've learned from them. So the first thing I'm going to focus on is what DXC and Tops are already currently, facing. So a really big thing is just refining the overall usability in the design. As we found with our testing, there's some concerns with the way that the database represents products and aisle locations that is not understandable to the shopper. So for example, milk might be labeled in dairy 4, because if you have a planogram with 4 sections, it would make sense that the 4th section would be milk. But the problem with that is grocery stores don't have like dairy aisles labeled. It'll be like aisle 18. And that's something that we as a team necessarily can't face unless we had those planograms. And Tops and Dixie has those. So they're working on that right now. Another issue that's of a very similar vein are end caps or bookends. So, you know, the end of the aisle, the little side pocket stand where you can find usually salsa or peanut butter or who knows what. That usually was labeled separately as bookend 49 instead of the end of aisle 13. They're different things that would really confuse a shopper and a user that they're currently working on. Another issue kind of within this vein that's being tweaked is how frequently the products get turned over and the database would need to be updated. We didn't really have access to when products were changed in the database, so we don't know when to set the refresh for our one single composite table, or which individual products were changed, because it's a lot easier to pull the few changes than it is to rebuild the entire database each time. So that's something that's currently in process. Another big thing, it's very similar to the dairy 14 to 18 issue, is the name of the products themselves. There's a lot of products that have abbreviated names like CHKN for chicken, but there's hundreds of thousands of products that all have different abbreviations, and we weren't able to create any sort of table to fix that and make it more user readable, but that's something that is probably currently in the works. But there's also certain things that we wish we could have done had we had more time or more resources. The first thing is a much more intelligent searching algorithm. We, after last semester, decided to look into Elasticsearch and a couple other solutions, and we proposed these to the team, but they felt that they didn't currently have the resources to support something like that, but it was something that they were very interested in the future. But we feel like this would really greatly improve the user experience, because if you're looking for Campbell's chicken soup and it returns roasted chicken, it's just not what you were looking for. Another thing that we thought that could be really useful was adding an interactive map. We felt that this would also help with some of those dairy and bookend inconsistencies, because if you had a map in the application that you could look at that had those kinds of bookends clearly marked, it might not be as big of an issue if the database is returning their planogram rather than the store itself.
Okay, so now I'm going to talk about some of the challenges we faced over the last 2 semesters, mostly in this one. So one of the biggest things that we encountered was with having a remote sponsor and using Skype for Business. We had some communications issues. Skype for Business doesn't work on every platform and is not always the most reliable thing. So we had to find a couple of workarounds, which was pretty good and worked pretty well. In regards to another thing with corporate tools, we had to prep for delivery to the sponsor. So prepping for IIS integration and deployment was probably most of the last couple of weeks, just getting everything ready for delivery. Another issue that we had was hosting and data privacy. So we'd approached the sponsor about hosting the website at some point, and we encountered some issues over data privacy and just the hops not being ready to just publish the data or make it available. And so we also didn't have enough resources to create that mock database for that, so it was kind of hard to get done. In regards to the database redesign, We had 3 different iterations, and as Laura already stated, it took a lot of time. I think the database redesign was the majority of the work in the project, especially on the technical end, and that was by far and away the hardest thing we had to overcome. So good work on that. And then testing on 4 different platforms. Again, for this, it was just the amount of time it took to actually set up the testing. The testing itself went pretty well, was pretty quick, but the amount of time it took to just set up all of these environments, as you guys saw on the previous slide, it just was very difficult. So, however, we have the positives. So we rapidly adjusted to what the sponsor needed, and a lot of times we had meetings every week, but we had a lot of changing requirements and updates to what the sponsor meant or wanted, and we were able to adjust to that. That was a significant amount of effort on our end, and we ended up having to change the data structure pretty frequently. So again, with the 3 iterations to redesigning the database, we were changing something pretty much every week, and just talking to the sponsor about it, discussing that. With flexible communication strategies, with the remote sponsor, we needed to have frequent email communication, and one of the biggest issues we encountered in the first semester was making sure that we were as clear as possible and everybody was getting the right message. Again, you guys know how difficult it is to get meaning across in text or just make sure everything is perfectly understood. We really overcame that in the second semester, and that was a really good improvement. Flexible and changing meeting times, especially since, again, with remote sponsors, we had people traveling, we had people who had time issues so they couldn't attend. We were able to kind of disseminate information pretty well between everyone, just especially it got better as the semester went on. And in the end, the sponsor was really happy with the end product, and we're hoping that it'll be put into use pretty soon, and the transition will go pretty smoothly. So, does anybody have any questions? Bueller.
So how is this application being deployed, or in what state is it handoff? How would somebody?
Well, they're currently working on getting it integrated on IIS. We actually didn't know last semester that we were planning on using the IIS. That was something that they told us closer to once it got to integration time. And we've been working with one of the architects, actually pretty much weekly, on getting it integrated into their structure. They, I think, have the server set up. They're working through some of the kinks with combining their 5 table and the 1 table into one overall database. So, does that answer your question?
Yeah.
Okay. Good.
So when you were talking about being at home and planning your trip to going and getting the product, I had a thought, and I was just wondering if you had also thought about this too. Did the feature, I guess, arise of adding a bunch of stuff to like a shopping cart of stuff you wanted to get, and not having like the optimum route through the store?
We didn't work with the store optimization much because there wasn't currently like a store map we received of how each store is laid out differently, so that can get really complex. But we have a lot of great feedback and features that we think would be really cool if TOPS or DXC wanted to work on them in the future. Thank you.
We did discuss like working on potentially a list. Sorry, I just wanted to make sure, like, we did talk about it, and it just was something that they didn't feel was necessary at this point in time.
I was just wondering.
Yeah. I think I saw one over there too, but it could have been.
Yes. So you mentioned data privacy, so could you tell a little more about what issue board resolution?
The data privacy issue was just they didn't want us to host their database, and for like someone came on our webpage, they could be like, oh, we could see where certain aisles are. I personally don't know the domain of security around grocery stores, but we understood that it was their data and we needed to secure it as much as we could.
Also, we did not feel very comfortable hosting the application with the actual database without doing like a full security testing on our application itself first, because we did not get to that point yet when we wanted to host initially.
Other questions? Let's thank the team.
Alright. Oh wait, we got our team spelled up. I'm gonna wow. That's pretty fast. Alright.
Hey everybody, thanks for coming out to our presentation. Yeah. So this is my teammate Nathan here. I'm Mackenzie, Colin, William, and Sadaf. Our team Pawns, that's Latin for bridge. That'll get more meaningful later on. We have our JP Morgan as our sponsor. Felix Schneer and John Casey, those guys have been really helpful throughout the entire process for us. And our faculty coach, Travis Tissell. So moving forward, we have a little bit of an outline. It's frozen on the screen, okay. Just a little bit of our background information first off, then we'll move into our problem, the requirements set out by JP Morgan and what we moved to tackle. Then we talk a little bit about our solution, how we came up with that. Then we'll show you our demonstration. After the demo, we will talk more about our architecture and decisions we made throughout the process. And then after that, we'll have a little bit of self-reflection.
Yeah, so before we get started, we're just going to quickly go over a few terms. Blockchain is basically a network that exists on the internet with lots of independent nodes that communicate with each other. You can store things like cryptocurrencies on there, pieces of code, and we'll get into that a little bit more in depth here soon. Ethereum is a specific blockchain that can hold smart contracts or basically other pieces of code that can either be automated or just exist to hold values and hold value in terms of like cryptocurrency, so you can trade them on exchanges, that sort of thing. Quorum is a fork of Ethereum that JP Morgan created for privatized like internal transactions. So this could be helpful for a bank potentially to exist on a blockchain someday. Web3j is how we're going to be communicating with each blockchain, each Quorum blockchain, and that's just through the Java instance, which we'll get more into shortly. And smart contracts, like I said, are basically pieces of code that exist on the blockchain that can execute certain tasks or store values, and that sort of thing. So the initial problem was kind of multifaceted. There were two big issues that we had to look at. First and foremost, there was really no industry standard for changing or for swapping an ERC20 token for an ERC721 token. These are two specific types of smart contracts that exist on the Ethereum network. One holds value in terms of like monetary value, so that can be the ERC20 token, so that would be something like a buck, basically, like $1 that exists on the blockchain. Whereas an ERC721 token is more of like a loan. It's a very specific instance of something. So yeah, we've been working with it as like a loan, pretty much, so it's like a mortgage for a house. So not only did we need to figure out how to swap those two tokens, those two different types of tokens, but we also had to figure out how to swap them across two distinct instances of different blockchains. So basically if you have blockchain A over here and blockchain B over here, how do we swap a token from blockchain A to blockchain B? And that was kind of the biggest issue, the biggest problem that we had to solve here. Our solution uses a bridge. Basically, it's a Java instance that's running a server that uses Web3j to communicate with each Quorum blockchain independently. The Java server, like I said, communicates with the Quorum networks, and the server can just be interacted with through your phone, through a served web page that we will be showing you shortly. We also added something called Escrow Wallets to this implementation, which is basically just an automated smart contract that exists within the Quorum network that will release funds based on certain criteria. And that is super helpful for adding like a third party, like an unbiased party involved in these transactions to not give somebody access to somebody else's funds without due process.
So now we're going to go through the system feature. So after we've been working in this project for almost 2 semesters, we have been able to deliver a couple good features. I would emphasize the most important feature we've been able to deliver is to perform a cross-blockchain transaction between ERC20 and ERC721 token at the moment. And along with that biggest feature requirement, we also have the front-end or user interaction to view token balance, and then we also build a user guide, so somebody can walk through step by step of the guide on how to actually use the application for the front end. And there is something else that we will not be able to fully deliver, is to provide a good security check when we actually perform the transaction across the blockchain at the moment. But we should be able to improve that in the future.
Okay, so now for our demonstration. So you've been put with a lot of terms that maybe you're unfamiliar with or don't understand. Throughout the demonstration, we're going to first show our front end. We're going to do one task, and then a visual is going to pop up to show you what in the back end or on the blockchain, what is happening. We're hoping this will help kind of relate what the front end's doing versus what the back end's doing. It'll kind of help both the people who super understand blockchain and those who don't. So without further ado, here is our demo. This is our landing page for our front end website. We're going to click on the Get Started tab. Now this is going to open the How It Works kind of section. This is a very detailed section of for someone new just getting into swapping these tokens. This is a step-by-step guide of both what you should do on the front end and then what's happening in the back end. So this adds transparency to our project. For our use case, we're going to have Bob and Alice. Bob has 500 ERC20 tokens. Alice has one ERC721 house, and they want to trade across two different blockchains. So what they're going to do is they're going to go to generate an escrow, and they're going to start typing in their information. For this demonstration, Alice is always addressed AAA, and Bob is always addressed BBB. These are simply addresses that they own and that they solely have access to. So we can see that they type in their address for both 20, 721, they put their amounts in, and then they're going to tie everything together with this passcode. This passcode is going to be used throughout the process to authenticate them to our system. So then they're going to click generate. So when they click generate, what just happened is through the backend, two escrow wallets were made. These are smart contracts which are going to deal with the transaction. You can think of these as simply a vault or a secure place on the blockchain that they can send their assets. When they get a confirmation it's been complete, they're going to get this address. This address is the destination to that vault or that safe place on the blockchain. They're going to save these for later use because they are, again, going to be used throughout the process. So now they're going to go to validate or review, and they're going to simply review what those transactions made. This can help if one party makes it and then they send these addresses over to someone else. They can both validate that whatever the addresses say is what they expect to happen. So Bob is going to give Alice 500, ERC20, and then Alice is going to give Bob the house. That's what that's validating. So now, once they validated that the contracts are correct, they are now going to deposit their assets into these secure escrow contracts. They're going to do this off of our site. There's various other ways to do this, and this was out of the scope of our project. But they're going to take their asset and they're going to transfer it into these escrow wallets, or these vaults, these safe places. We're now going to simply review that whatever asset they said is going to be there is now going to be in the escrow. So we have our 20 and our escrow for ERC20 address. We see that there's 500 there. We're now going to do the same thing for our 721, and we see that there's one token, ERC721, in there. So both of the assets have now successfully been transferred to the escrow outside of this project. So now we're going to finish the transaction for both 20 and 721. We're going to hit we're going to put in our address. So that's the address to that escrow contract for this, specifically 20. We're going to put in the passcode, and now we see that our funds have been successfully transferred. So the escrow has released that fund and given it to the other party. So that's one step. Now we have to do the other side, or the other blockchain. So now we need Alice to approve to go over to Bob. So we're going to say the same thing. We're going to put in our ERC721 escrow address this time. Same password. We're going to hit submit. And then we're going to see at the bottom that the transaction has successfully been completed, completing the full swap. So we went from Bob to Alice, Alice to Bob. To validate that all of this happened correctly, we're again going to use our get balance functionality in our front end, and we're going to check to make sure each account has what we believe it should. So this is the escrow. The escrow originally contained 1, now it contains 0, because it doesn't own that asset anymore. Likewise, for the ERC721 escrow, it used to contain 500, now it contains 0, because it no longer has those assets. We're now going to check Alice. Alice should have 500 ERC20s, which she does. And now we're going to do the same thing for Bob at BBB, and he should have the one ERC 721 transferred from Alice. For an overview of what just happened, Bob gave his asset to his escrow. That escrow then authenticated, or that escrow was then approved to give the asset to Alice on one blockchain. On the separate blockchain, Alice gave her asset to her escrow, and then that escrow was approved to give it to Bob, successfully swapping both tokens.
Yeah, so as you could probably tell, we have a front end that's just based on a like a web page that communicates with the Java backend. And then the Java backend uses Web3j to communicate with two 3-node quorum instances. So these are just two distinct, two separate quorum blockchains running on 3 nodes and that are completely separate from each other running on the backend.
So here is our progress from last semester to this semester. In this table you can see that last semester we had to do a lot of research basically on how blockchain works, how smart contracts are executed on a blockchain, and the structure of ERC 721 and ERC 20 tokens. So last semester our main goal was to get the basic swap functionality working on the console. Fast forward to this semester, we implemented escrow wallets, improved security on smart contracts using the escrow wallets, as well as creating a front end for our product. And then we added some final touches to the bridge, and then lastly we bridged our front end with our back end.
So now, some issues we had. Specifically for Solidity and Web3j, Solidity is what the smart contracts are written in on the blockchain. That was an unfamiliar technology to almost all of us, and so there was a very kind of steep barrier to entry to understand first what the blockchain was doing, and then how Solidity kind of interacted with the blockchain. Web3j was slightly more straightforward. Because of Web3j, which is Java-based, we chose a Spring Boot backend so that we could easily integrate with Web3j, which would then talk through through Web3j into our two blockchains. Another difficulty we had during implementation was debugging. Unlike other languages, when you mess up or when you have a runtime error on a blockchain, there's no great way to figure out what happened. We did use third-party kind of test networks, which gave a little more transparency of what was happening. However, when we started converting them all over to Quorum, we did run into a lot of issues. We'd like to thank the Quorum team because they helped kind of throughout this debugging process because they were a lot more knowledgeable and they've kind of already been through this, these barriers. So kind of a demonstration of what we're talking about. This is a Java runtime error. This is an array index out of bound exception, which I'm sure we've all seen at one point or another. So as we can see, it very clearly says that there's an error on line 6 of hello-world.java. On a blockchain error, you, if you can find it, can eventually get to this. This is, in order to get here, you need to find your transaction hash, which if you print it is easy. If you don't print it, then you have to find your block. And then in the block, you have to find the transactions, and then the transactions, you have to find your specific transaction, and then you can get here. And the only thing that's given here is the status. If the status is 0, then it's false, and then your transaction failed. If it's 1, then the transaction succeeded, which means that the script was successfully run. However, you may have had other errors in there which have prevented what you thought was happening. We had the biggest trouble with ERC 721 trying to transfer it over. Either it wouldn't transfer, or it would go somewhere that we don't know. And so that was kind of our biggest issue when dealing with the blockchain.
So after we've been going through with the back end, issue, now comes the front end. There's also a lot of difficult decision and challenge we've been facing as we create a front end application to test and interact with our back end. So first is the hosting decision. We kind of struggle a little bit at the beginning to see how to host on a VM or where to host the application so we can access it easy. And the second thing is an API endpoint. This is very important because when we design the architecture on the back end, every functionality, we're using an API feature, so every function from the back end transfer to the front end through an API. So if one feature not working correctly, it will not affect a different feature, and we can debugging it easier as we observe the behavior on the front end. Just like Nathan said earlier, some transaction might not go through correctly, and we can see it easier through the front end than just straight up on the back end. And the next is, view information, or, how to view, what information to view, and how much information we should display is another big decision that we make. And some challenges, we still not be able to do a lot of security checking, and it's not really a good idea to let everybody to use the application and check all kind of information they want through the front end. So that's another challenge we not be able to do it totally finished. And another thing is for the user and mobile friendly. So as we're making the application, there's so many information for the new user. This can be overwhelming, and you might get lost on the way through. So we're trying to make it as easy as possible, so it's not painful to go through the application.
All right, so moving forward, we're going to do a little bit of a self-reflection of what we can improve on and what worked really well. So we'll start out with the negatives. There are a lot of hard-to-find problems, as Nathan already mentioned. A lot of new domain that we had to work through, and finding little issues took longer than we expected. As any school project, you can get affected by team absences. Working through that, though, staying on the same page, that's always something to improve on. We did have Slack communication, and we're always talking and updating each other, but to have two separate teams within our small team already, I'll talk a little bit more about that. Staying on the same page can be a little bit of a challenge with a new topic. And then lastly, for things to improve on, a great process for a research project, we kind of found ourselves just going out and doing little experimental processes. We didn't really find like a smooth fit for a specific methodology to follow. But to the positives of things that worked really well, we completed the full swap. It was a completely research and experiment focused project, and we're happy to say that we completed it with the help of JP Morgan. We got that full swap done. The separated teams did work for the most part, having a front end and a back end team coming to work together on small pieces of work. And then again, the team to sponsor relationship was really helpful. We had a Slack where we could ask them questions anytime. Moving forward to a little bit of the major lessons learned. The first one definitely is learn domain topics early. So if any projects here in the future have to take on a largely research-focused project, definitely dive into those topics early and make sure everyone's reading up on it, because if you guys aren't already lost by our demonstration, that's a lot of new terms, a lot of new technology. Dividing the work again in small pieces really helped. Keeping it agile, as cliche as it sounds, really helped. Research projects are different. I feel like we've already said that. Communication is key, definitely. That's a major takeaway for this project. Being able to talk to your teammates and talk to your sponsors. We had the benefit of using Slack, which really helped, because although we only had weekly meetings, we were able to really talk through and handle our problems quickly.
So for future work, one of the main things we wanted to implement was provide a history of transactions. So on the same page, you guys saw in our demo that we were able to get a balance and able to do the actual swap. We also wanted to implement the feature of getting the history of transactions, so that, let's say if someone does perform the swap, they can see it in their history of transactions or any other transactions they ever made. And then another feature that Quorum has is that we're able to make things fully private for the exchanges, for the parties. In our product right now, it's just public, so that's another thing that that we plan to do. And then lastly, the concept of blockchain is that it's decentralized, that there's no human intervention. And right now, the way our product works is that we go in, run the server, and then we can use the UI to communicate with our backend. So right now, that's another thing we plan to work on. And then lastly, our product does require a bit of trust for both parties. In the future, we want to make our product trustless, like sort of how decentralized finance is right now. So, any questions?
Yes.
So you just mentioned that the product still requires a little bit of trust. Where exactly is that?
Yeah, so currently what's happening is each individual will release the fund from their escrow wallet based on a passcode. What we would like to do is eventually set it up so that that release sort of happens automatically at a set tick or like at a set time. We also originally were planning on having like a timeout function, so like after a certain period of time, the funds will just go back to the person that originally sent them. But due to the complex domain and just us getting used to working with the stuff, we didn't have time to implement that. But that's definitely something that if this was ever in industry, in a place where it's used frequently, those features would need to be implemented.
Okay, so that transaction error, that is not atomic?
No, I believe it's
So the transaction itself is atomic, yes.
Yeah.
As soon as it's in the escrow, it's atomic. They have a delay, or there's a time period. So they either can take out their funds, or if they wait too long, it's returned to the original party. Where our issue lies is if one party gives the escrow their asset, and the other one just doesn't.
Just never releases their
Ever
funds.
does.
Yeah.
That's our current, that's a major security risk for our current implementation.
So that's a situation where one party ends up with full.
Potentially.
Yes, so
And that's
why we said there is some amount of trust between the parties currently. Yes. Yep.
So it seems like a really domain-heavy project, honestly. So with everything kind of two parts. Firstly, do you feel like you all are pretty equally well-versed in like blockchain in this domain now, or do you not know experts? And did you enjoy having a project that was so focused on like one specific domain? Like, I find it hard to separate out like the actual code and the domain project.
We're fortunate in that we had a pretty large team. I pretty much specialized in like the solidity and like playing with the smart contracts and making sure things work on the test nets and actually getting into the Ethereum code. But I think that we all had a good general idea with like what was going on. I mean, everybody does different things in a project, obviously, and those differences are more obvious, I think, in a domain-heavy project like this.
Yeah.
What was the other part? What was the other part?
I have a question. So when you were showing your architecture, what was the need for the free form service, or is that part of how things are activated, generated, or what?
Yeah, so the two independent quorum blockchains that are running, that was part of the problem that was brought to us in the beginning of the first semester was, so say we have two specific blockchains running, right? How do we do a swap across each of those or both of those blockchains? So that's more specific towards the problem that JP Morgan brought to us, or that I guess we signed up for. So that's not specific. So the switching of tokens isn't necessarily has to be done across two specific blockchains. That's just part of the problem that we took.
So these are just two target ones going to be tested, right? Source and right. But there's a third one. So I'm just
Sure. Yeah. So there's three nodes on each blockchain, and so they're just a network. And so how the blockchain work is they're decentralized, so they each have to agree. The three nodes together make up one blockchain.
The minimum.
Yeah, exactly.
Yep.
And that was, like you said, that's the minimum requirement for quorum to run correctly. So we just picked three because it ran on the server without having issues.
And again, Alice can walk away with her money, right?
So if you're in a trusted environment where each person is going through the transactions together at the same time, that probably won't happen. But with the current implementation, that is possible. So that's something that we would have to add in the future in order to increase security.
So we're Team Celestial Orca. I'm Philip. This is Matt, Aaron, and Dan. Our project coach is Kyle, and our sponsor is Biz Cloud Experts, and we'll be presenting on our product, the Info Kiosk. So the problem we faced was a traditional bulletin board system where someone goes and they post notices, they post messages, and passerbys look at them for information. The downfall here is that over time it gets very cluttered because no one comes and removes the notices or removes any of the messages.
So after hearing the problem, our team's solution was to create an electronic bulletin system that really helps clean up the clutter that you saw on the previous slide. And this system is composed of 3 distinct parts, which is the Smart TV, which helps display the content to our end users, the web application, which helps push the content to the Smart TV, and the cloud service, which really ties both of these applications together. So after looking at the entire system as a whole, I'm going to talk specifically on the Smart TV app and its environment and the key features. So for our choice of Smart TV, we decided on Android TV because there was a wide support on multiple devices compared to other competitors, and we used 2 libraries to help build the Smart TV app, the Android Leanback library and the Amazon IoT library. And the Amazon IoT library was very crucial because it communicates the Smart TV app with the cloud service using a pub-sub protocol. So for the Smart TV key features, the first one I would say would be the client Smart TV registration. And for registering a device, it is clearly important that it provides a secure layer for the client to know where its content is going to and who is submitting content to the device. The second key feature would be displaying the content on the Smart TV. And this was what really what we needed to tackle, because from the previous slide you saw all those posts on the board which cluttered it. By displaying our content in a tile-like card format, each content is clearly visible and it'll have both the description, title, and a QR code present on the content card, which really speaks on the third point, which is having a QR code generated for that specific content. For our fourth point, we wanted our users to be able to submit requests to push their content on the TV. And this is done by going up to the Smart TV, pulling out your phone, scanning a QR code that's found on the TV, and this will take you to a website where you can submit the content. And Phil will talk more about that later. And finally, our real-time updates. For real-time updates, we wanted our content to be pushed to the TV very seamlessly. And to do that, the page will just refresh and load the new card. And now I'll just hand it off to Phil to speak more on the web app.
So here are some tools that we use to develop the web app. These are very important to highlight because they were requested either directly by the sponsor or they directly handle the requirement that we elicited from the sponsor. So here we use Angular. The sponsor directly requested us to use Angular because that's what they use in-house, so it allows for easy transferability of the project at the end. We use Material to design the project because there's Angular Material Framework, so it allowed us to easily roll out Material components. AWS Cognito for authentication, things like email notifications upon registration were something that the sponsor also requested, so we were able to deliver that feature with using Cognito, and hosting and serving the website via S3 buckets and CloudFront. So some of the key features, like I said before, authentication authorization through AWS Cognito. We also had a registration flow through invitation, so we didn't want any random user to be able to go to the website and register as a user. Also, the ability to add content and clients and sections, so different types of users can go on and add to their client, to their section. A client would be any institution, and a section would be any department in that institution. For example, RIT would be an institution, and a section would be Golisano. The ability to approve and deny content that's either added or submitted through a content request. So submit, like Aaron said before, you can go up and submit a content request through the web application, and then an administrator could go onto the web application and approve or deny that content depending on different criteria. And also, like Aaron stated before, the device registration requests can also be approved and denied by different administrators. You can also list all content, clients, sections, devices, and users on the web application, and we can also push the content in real time to the smart TV.
So for our solution, we had 4 major design constraints that really drove our system architecture. The first one was real-time updates, as mentioned by Aaron. So for the smart TV, we need to be able to push content real time, so that way we know the content on the TV is always up to date. The second one was QR code functionality. So as you will see in the demo later, when you see a content tile, you'll just see a short description, but if you want to see more information, you can scan the QR code with your phone, and that will show you, that will take you to a website where you can have more information or any extra content you want to see. The third constraint was serverless. The sponsor wanted us to make a serverless application so that we wouldn't have to provision servers, and that will also make our application highly scalable and easy to manage. And the fourth one was unique device registration. For unique device registration, we wanted to be able to uniquely identify each smart TV that was registered to the system, so you can push to individual TVs and monitor what's on an individual TV. So how does it work? For our solution to tackle each of these constraints, we used AWS IoT, which allowed us to use an MQTT publish subscription protocol. And that protocol allows the TV to subscribe to an IoT topic, and then the web app pushes messages to that subscription, so that way the TV knows when to publish new information, and that way it always gets real-time updates. For the QR code, we used Java and Android's built-in bitmap libraries, so that way we can dynamically generate a QR code which maps to a link, so if you scan it, it takes you to a link. For the serverless architecture, we used AWS API Gateway and AWS Lambda. API Gateway basically allows you to create a REST API that links to each Lambda, and Lambda is basically a compute service that allows you to run code without provisioning servers. For Cognito and RDS, we use that for unique device registration. As Phil said, Cognito is used for our user registration. Pairing that with RDS, which is Amazon's relational database service, we are able to store our MySQL server and then connect each device that is logged there and tie it to a user. And then this is the overall system architecture I was talking about. On the top, you have the web app and the TV app. The web app, all static content is stored in S3, as Phil said, and then user authors through Amazon Cognito. The web app and the TV app are both linked to API Gateway, which links to AWS Lambda to hit the database or perform any backend actions. On the right side, you see AWS IoT. The TV registers or subscribes to MQTT topic on IoT, and then when the web app pushes a notification using Lambda, it will pull new content using Lambda from the database. And now I'll show a demo. And for the demo, we'll show a full walkthrough of registering a smart TV. For this, we used the NVIDIA Shield, and then pushing content to that TV. So here, I'm just going to start the app. In the beginning, when you open it, you're taken to a welcome screen, and then you can put in your client ID. This is what I was talking about when you want to tie a smart TV to a specific client. So for this client, we're using RIT. So each user will have their own client ID so they can uniquely register devices to their own account as like a security layer. So once you put it in, you hit done to request register, and then instantly you'll see a status page saying that it's pending. When you log into the web app, here I'm logging in as a client account. That way I can approve device requests. So I log in, and then we're taken to a content homepage. This will be like your overall, like when you first log in the dashboard, you'll see content here. On the top, you can access your content, your sections, devices, and users. Sections, for example, are if you have a specific, like Golisano might be a section, or Gosno will be a section, so that we can manage where your devices are registered to. So we'll go to device request, and our most recent device request at the bottom is 49. It has no name yet because we haven't registered it in our system. So we hit approve. The client is RIT, and then for the device name, I'll put Senior Product Demo. And then we're allowed to select a section, and since we're in Jesus, I'm going to select Jesus as a section. And then behind the TV, there's an accept button. And then as soon as the device is registered in the system, the Smart TV should update. On the right, it's been approved, and now we're on like our home screen. As you see here in the list of devices, we have the Senior Project Demo device, and then you can see other devices in your system along with the section that they're in. So we'll go to content. As we showed before, we have one content already in the system, and that content is the Imagine RIT that's coming up this weekend. So for this, I want to push it to my device. So I go to the right under push. I can select the device in our client account. As you see, it has all the information for the content. And then, after you hit push, it should update on the TV here, and then you see the content tile. And that's the QR code to scan if you want more information. So then, going back to content, a user is also able to generate content on the web app. So here, behind the TV, there's a little plus symbol. But I wanted to show the real-time update, so that's why I left the TV in the corner. You can create a new content if you want. So for this content, I'm just going to do a demo content. And you can put in a headline, description, URL. The QR code will be tied to whatever you put in the URL field. So when I add the new content, it shows up in the content list, but it's not pushed to the TV yet. So now I'll push it to the TV the same way I did before. I select the device, Senior Project Demo, hit push, and then automatically updates on the Smart TV. As you can see here, and then you'll be able to scan a QR code. So then here, I wanted to show as a user to request new content. So there's a QR code in the top left, and then you might see it. I take my phone and I scan the QR code. So basically that allows you to, if you're a user, you can walk up to the TV, scan the QR code, and it'll automatically take you to a link where you can submit content if you're an end user. You don't have to create an account. You can just scan that link and then submit a content request if you want to publish content. So here I'm typing in the link, taking from my phone, and then that'll take you to the content request page. Here you can put in a headline, a description, URL, and then an email so that you'll be notified when your content is ready to be, when it's been approved. So here I'll put SC posters. For the description, I'll put that it's located in the atrium. And then the URL, I'll link to the SE website. And then I'll put my own personal email so that I know when my content has been approved. As you can see here on the bottom, the client name and the device name is pre-populated, so because if the user scans the QR code, it takes them to that specific TV for posting. And then once I hit submit, you get a confirmation page, thank you for submitting, turn to dashboard. And then a client account would sign in, see the new content. So up here you can see there's content that's pending. So to approve that content, you go to the top left to content request. And then you'll see the content that's being requested, all the information that I put in. And then you hit approve. And then as you hit approve, the Smart TV automatically updates with the new information. And then, as you can see here, it has all three cards. So for here, I wanted to show that on the website, you can see the status of any TV at any time. So if I go to content, even though that TV is in like a off state, you can see that this content is currently active on the TV. So if I click to the TV again, or if I turn it off and turn it on, it automatically comes back to that state. And then this next part of the demo is just showing that TVs will save state no matter if you close the application, turn them off, or turn them on again. So as you can see here, I go to applications and I start InfoKiosk app. It takes you to the same splash screen, but it knows it's registered and will automatically take you to the Smart TV content.
All right, so how did we accomplish all this? Well, in the beginning of the semester, we wrote out a project plan, and we wrote out goals that we wanted to achieve for each sprint. As we progressed through the semester, the goals for each sprint changed based on different priorities. One good example of this was we originally wanted to implement our UI towards the end of the semester. However, our sponsor and our project coach both didn't quite think that was a good idea, so we had to restructure our sprints and our goals for our sprints to meet those needs. Currently, we're in pretty much the same state as every other senior project team, where we're just tidying up, getting ready for handoff, and getting all of our documentation ready. So some challenges we faced for the project. Big one, time management. We've got jobs, we've got, other classes that we need to take care of, so it was hard to always commit a consistent amount of hours to the project. A lot of the technology that we used was unfamiliar to us. We didn't know how the architecture of the smart TV worked. We may have known Java, which is what it's written in, but we didn't know really anything about the smart TV itself. So that took a lot of research and looking into. We didn't know much about Cognito and how we wanted to represent users, whether we wanted to use the database alone, some combination of the two, or just Cognito. And both Angular and Material, we all had a steep ramp up on those as well because we weren't totally familiar with that technology. That being said, a lot of that, we didn't miss a few deadlines. Our sprints were structured in 2-week sprints, and everything was supposed to be done by Friday. That was the end of our sprint. Our development was supposed to be done by that Tuesday, and then that would allow us to test between that and Thursday when we presented to our sponsor. Oftentimes, we didn't quite get the development done by that Tuesday agreed upon time, which pushed testing back, and sometimes that kind of just fell into the following sprint. So that was a huge challenge that we faced. However, we did have some relative success in overcoming that. In the first semester, we had a very kind of loose process. We started leaning towards a better, more structured, agile process. But really, in the second semester, we implemented a Scrum-Ban process. We did daily stand-ups, and we used Jira for our project management. And this really helped the visibility of our project, of our status, and being able to track how we're doing. Another thing that helped our ability to deliver the product was code pipeline and having automated tests, unit tests for our backend code. So essentially, backend tests would be run on the master branch before deploying code to the cloud, and excuse me, sorry, and then code pipeline would then push it to the cloud. Overall, we learned a lot about the project, and most of the functionality that we wanted to get done that we planned out at the beginning of the semester, we accomplished. That being said, the one feature at the top that we didn't get to that we did plan on delivering was limiting the amount of content to be pushed to one device. Originally, we wanted to have a limit so that if, say, a device could hold 10 content, once you pushed an 11th piece of content to that device, it would boot the oldest piece of content off the device. Right now, the workaround for this is it's really kind of just, it expands. The 11th content goes to the TV, and you can then scroll the list up to view all the content. The middle three were things that we kind of figured out as the project went along and didn't quite get to. And everything at the bottom is more or less things that were discussed with the project sponsor that we deemed more or less out of scope for this semester in favor of the core functionality that we did deliver before all this extra functionality. That being said, I do think it's a good idea to omit that because together we put in about 800 hours this semester. We've come a long way since the first semester, and I think if we had added anything else, we wouldn't have been nearly as successful at delivering the project as promised. Back.
Yeah. So, at the very beginning, you said one of the biggest problems is existing bulletin boards and the content gets out of date. Do you have anything in this project that helps solve that problem?
What we're saying the content gets out of date, we're saying it's stale and then it stays there and no one updates it. So as no one either removes it or updates it with, new information, it will just clutter the board. So in this case, yeah, like the active status buttons and things like that, you can remove content that's old. You can push new content that's newer and remove older content, etc. That's kind of what we were alluding to.
And then also in the database, each content has a time push. So our sponsor wanted, for now, have 24 hours content before expiration. So as you saw, some of those had status reserve. Status reserve means that it wouldn't be deleted after 24 hours. However, if somebody, for example, the content that I requested was status approved, that one would get pushed away after 24 hours unless stated otherwise.
That's a lot of AWS tools. How do you keep costs low for your sponsor?
So our sponsor is actually AWS cloud consultant. So they had their own AWS instance, and then they kind of gave us what resources we could use. However, we saved a lot of money using AWS Lambda, for example, instead of having to spin up servers. I think the cost of AWS Lambda is like a nanodollar per millisecond for your computation. So a lot of these, let's say I wanted to make a request to the database, it's runs in less than a second, so it costs less than a penny.
So on the content paper, you have all the content listed out, but if something goes up as requested from the community, did you consider having the approval and review status page sort of integrated into that so they didn't have to switch between pages and make that extra request, or is that sort of something that explicitly decided against?
So are you just asking pretty much why is the content list separate from the content request list? They're kind of separate entities in a way. I mean, we didn't really think about, I guess, integrating those together just to, realistically, we would have had, as you may have seen, like a search or a filter. So if we had that built into the lists, you would be able to look for something with a status of, not pending or whatever, or waiting to be approved. But we didn't have that yet, so this is the best solution. And in the list view, it's really limited as to what you can see, but as you saw in the content request, you could see a little bit more and then have the functionality to approve or deny it. So yeah, I don't know. Hopefully that answers your question. I mean, yeah.
All right, thank you.
All right. So
We are Team Jaw. That is Jonathan, Austin, Adam, and myself, William. And we are the development team behind Presence VR. Presence VR is a virtual reality web app interviewing system that is a second phase project. That means there was a senior project working on this last year that proved feasibility of virtual reality web apps, and then we have taken their prototype and transformed it into a full functional web application. So the initial, click on it. The initial problem statement that we had was to ensure that virtual reality could be used for an interviewing process. The modern interview is not ideal. Either your first choice is you send out interviewers to go find students that they could employ or possible employees, which is an expensive process, or if you choose to circumvent that by using something, for example, phone or the Skype style interviewing process, you're losing a lot of what is that presence that allows you to really understand what an employee could offer to your company. So what happened is that last team took that idea, that problem statement, and wanted to prove that virtual reality could be a feasible solution. They looked at the technologies, they created some sort of prototype application that proved that yes, we could use the existing technologies in order to create this web application. And we took that, especially over last semester, and started to create that interview platform using our web application. And it was successful, and we were able to create a web app in order to host that. But as we continued to make this project, we discovered that there's much more to this. There's a lot more depth and a lot more flexibility to the application that we're making. Why just focus on only the virtual reality interviewing project when we can make a much more general purpose platform that can reach a much broader audience? We're going to continue to focus on the use case of our sponsor, making sure that the art interview, making sure that any student who wants to get their resume out there to as many employers as possible is able to do that. But we think we can continue to broaden that scope and make it better and more robust for a wider use of applications. So this is a little demonstration of the prototype that got completed from last year's project, just proving feasibility. You can see you're able to create a general room. There's a single page that everybody sees, no matter who you are. There's no idea of a user. And once you go in, you see this. You're able to enable a webcam and do that kind of face-to-face view, or you're able to enter into a 360 image in which there's kind of one image stretched all the way around you, and you're able to maneuver in that image while someone else is presented. You can see, obviously, being able to interact and create presence in that is not exactly ideal. It stretches the landscape, and there's, it just proved that this is possible to create a virtual reality application. So, moving forward, we had a few technical problems, that we're trying to solve, given to us by our sponsor. The first thing is, okay, we want to take this project and make it completely dynamic. We want to make something that allows people to, create dynamic conferencing, putting multiple people into a room and able to communicate with each other. And the other big task given to us by our sponsor is we really need high quality imaging. We want to make sure that, especially for that art student, that they're able to upload that artwork, and that if you take a look inside that virtual reality, it gives it full justice rather than being pixelated like we did see in that prototype. We want to make sure that it's accessible to as many people as possible. This means making that web application as opposed to something that's hardware specific, and making it work on as many different platforms and technologies as possible. So our proposed solution for this is to take that virtual reality platform, make it one to end users. Any number of people are able to enter in this virtual space. You're able to spin up your own virtual environment and then enter into that using all sorts of mediums. So including virtual reality, you're able to work on that in just the browser or put on the headset and actually interact with each other. Or you're able to do a video conferencing like that, Skype or face-to-face conversation in that virtual space. And we made sure we were able to support multiple headsets, so that includes using the Vive or the Oculus, or including using your mobile phone, which the app is fully supported in mobile, putting on, for example, the Google Cardboard, which is probably the cheapest virtual reality solution out there. And this is supported using Mozilla and Chrome, and we made sure we're implementing authentication. Our goal is to make sure that the user experience is at the peak, as this is a development project for actual release. And we want to make sure everything is secure with high quality and that we have a full deployment that is available to the public and usable after our project is completed. So the stack that we used the same stack as the last team. They proved that it was feasible. But to note here, we are using Firebase and Cloud in order to host, and we're using network A-frame on top of A-frame, so that way we can communicate and connect the networks together. And Twilio is doing the same thing using the webcam feature there. The overall architecture, what I want to point out here is it's similar to what we used last time, built off of the concept from the previous team, but we are creating sockets in order to communicate back and forth, making everything dynamic and update in real time, and then that is being pushed forward onto the React interface. As you can see, we are exposing two things from the back end. We're going to view those actual interview objects that each person is able to create and share to other clients, and then the uploads, which are the actual assets you create, like your artwork inside of the space. And then you're able to use your Google account in order to log in. It is all connected by your own Google account.
So let's introduce our web app, starting with conferencing and general features. Here's our basic login flow. All routes and views are protected with Google authentication. We chose this for easy integration with RIT Google accounts and regular accounts. Here you can see someone signing in and signing out. There are many features we could have added for accessibility purposes, and while we did not have much time at all for these types of minor features, we did add a few. One example is the night mode you can see here, a common feature in web pages these days. Here we have our interview object. We expose standard CRUD operations through our REST API, and all operations for our interview object are available throughout the app. Here you can see that someone will edit the interview object. It'll update on the side, and then here's the delete operation. All clients can connect to an instant messaging chat that also serves as a system log. You can see the two people talk to each other, and then someone has left the room. Here's an example of our basic video chat function for a video conferencing experience. Every video stream is dynamically formatted to fit all webcams within a predetermined space. Your webcam is on the top, while the rest will be grouped below. There's me and Austin waving at each other. In addition to synchronizing with the database, all client changes are transmitted over socket connections. Presentation edits, client mode changes, VR changes, all get broadcasted over the socket, updating all clients attached to this particular interview at the same time. Here you can see the environment just changed. In a few seconds, you will see that someone has entered video chat mode. In another few seconds, you can see someone will be added on my left, your right. There's someone added, and then someone, I believe, leaves the room. Yeah. There was a lot of work behind the scenes. We upgraded React and Webpack. We audited and fixed something around 186 NPM vulnerabilities, along with countless linting errors. And we have a stable deployment. We'll went a little bit into that. One of the biggest challenges for us was mitigating scope creep. With such an open-ended project, in addition to our non-specific requirements, the possible features we could have added were endless. We really had to explicitly define which requirements we deemed was most important to us. We spent a lot of time, over a month, talking with our sponsor to lock down the most important requirements that we wanted to pursue. For instance, when we started making the initial prototype, one of the requirements we wanted to add was a calendar. However, through conversations with our sponsor, we decided that this was not important. It's decisions like these we had to make to not only define the project, but also define requirements that we thought we could complete within our allotted time. In addition to our requirements problem, we, as a whole group, were also very unfamiliar with the VR domain. A lot of the time we spent on the web application, we also spent researching and familiarizing ourselves with the VR domain.
Right, so now that that kind of infrastructure work is out of the way, I want to take you through some of the general features of like the virtual reality experience itself that's inside of the platform. So we support 3 types of assets. This was kind of the bread and butter at the beginning. The prototype, we didn't show it, but the basic idea was that you could upload an object file. So we wanted to support images, objects, and videos. We do support JPGs and PNGs. This is just a demonstration of that. An image, a video in real time of some jellyfish, and then an OBJ. Going back to that first use case, if you think about like, mechanical engineers, they can export their CAD workshops as OBJs, and to get that in these kind of interviews, the art is kind of self-explanatory. Something else that we had to do, this was specific for our sponsor. We talked about making a general platform that supports a lot of modes, so that can mean 2 people in VR, that can mean 1 person in browser, 1 in VR, maybe another in video conferencing. But for one particular use case, we wanted to make sure that the presenter's camera gets broadcast inside the VR experience. So if someone's in a headset and they're observing your work, they're going to see a static and following feed of the presenter. You can see that down at the bottom right. That's not overlaid in the web page, that's actually in the VR. So anyone with the headset on would see that. Another bread and butter kind of thing that we set up was environment changes. At the moment, we're using 4 default configuration environments. We talked with the sponsor. This was a classic requirement solicitation problem. We could have spent time creating custom environments that more adequately mock an interview experience. But none of us are digital design majors, so we kind of put that to the side, either for the next team or for collaboration for future work. After the general features were out of the way, that allowed us to move on to multiplayer, which is kind of the backbone of the interview experience. So the first thing that we had to do was get teleportation. Every user had to have an avatar. They are a little bit creepy. I'm sorry about that, but you get used to it, I promise. We had to add avatars for every user that connected to the room to kind of have some basic semblance of presence. With that, rotation in the headset is tracked and synchronized between users, and so is position. So when we added teleport to move around the map, all clients will see that broadcast. This was a big technical challenge, but now we've got asset upload. How do we make that multiplayer and in a way that's secure? So real-time asset networking. All assets uploaded by all users are linked to that account, which means our server will only statically serve you your assets. No one else can access them through the front end or the back end. So what you're seeing in this GIF is a user connect. You're seeing their assets drawn, and when they leave, their assets go with them. We didn't want to create a situation where your assets were left open to other users without your knowledge or consent. So obviously they're free to screen cap or record while you're in the interview, but you have the peace of mind that they're not exposed wrongfully by the server. And then once we had that basic groundwork laid, what we wanted to move on to support was interactions. So in this GIF, we're just going to show you a remote client is moving around their own assets. They're also scaling up and down their assets. And since this is a GIF, you don't know, but audio is also transmitted. So all of our asset formats follow these same rules and will broadcast the same data. So if you upload art and you're not content with the resolution that it's at, you're free to scale it up or down. And that will broadcast in real time with no delay to all the other users. Behind the scenes, I can't emphasize how much stuff doesn't fit in a GIF. The biggest problem probably was making cross-platform support. So everything you just saw works generically. It'll work in all the major vendor headsets. Vive and Oculus were our targets. We tested in Daydream, and if I had to guess, given the hardware, it would also work in Samsung VR. So we built those layers of abstraction for that purpose specifically. There was a lot of re-rendering kind of trickery under the scenes. If you noticed when I was adding those assets, the page didn't reload to the user. They were dynamically injected into the rendering engine. This was to create an experience that's not disrupted in the event that one user's in a headset, another user adds an asset, and both see a page refresh. That would be a very disruptive experience. So yeah, that's the dynamic rendering engine. Images scale by resolution. We support very large images and assets, so we have a scaling system that kind of maps them to the virtual space. Additional challenges. As it turns out,
having webcam broadcast inside of VR in real time is very difficult. And assets, we created a pipeline for adding more to the system. Obviously, future work would include adding more file asset formats.
All right, so let's take a look at our retrospective. So one of our major goals was to improve the image quality from the previous app. This is an asset we took from the previous application. I think the image speaks for itself. But we worked hard to improve the image quality, and as you can see, it's a lot clearer with this, and it's very easy to see with especially a bunch of different image sizes too. We were able to scale the resolution based on the image, so it doesn't stretch or get warped when it gets added into the VR. And then another thing we wanted to improve on was the performance. So this is a 11.5 thousand by 6.5 thousand pixel image that we're able to render and unrender into our app in under less than a second with very little latency. So some of the difficulties and successes we had were, one of the big ones is that the A-frame toolchain and just VR toolchain in general is very green. Everything we were using as far as the VR is still not in 1.0 yet. So there are a lot of missing and features that we could use or we would want to use that might not be implemented yet. So a lot of things we had to do, we kind of had to find ways to kind of work around that. Another thing is that a lot of the docs we could use as far as for reference were out of date or weren't really supported anymore by their creators. So as far as looking for help, we were mostly on our own as far as that and trying to use out-of-date docs to kind of piece things together and figure out solutions. Lastly, the framework we use for multiplayer network A-frame, the creator of it kind of stopped supporting it like 8 months ago, I think. So that became kind of difficult because there were a lot of missing features as far as that. And as far as support went, there was very little help for that as well. The other thing is that there is a very shallow VR experience currently just because of time constraints. There were a lot of things we would have loved to do if we had more time, but unfortunately, not given that, it was very tough. So the experience right now is very basic, but we tried to get the bare bones in there so you could have a core experience that you could build off of. We had a bunch of successes though. The big one being we hit all of our proposed goals. We sat down at the beginning of this semester and tried to hammer out what we really wanted to get done by the end of the year, and we were able to hit all of those requirements and then even a few more on top of that. And we were able to create a fully dynamic VR platform where you could kind of move in between modes and not have it affect other users. And then also everything within the application is dynamic too, such as uploading assets, rendering and unrendering. Nothing is really hard-coded. And the other big one was cross-platform support was a huge one we hit. So this way, because the whole point of the application was that you wouldn't need to have like a specific computer in order to use it. This way you could use like a mid-level laptop and essentially run the application with or without the VR. So some future work that we have planned for a team to work on in the future is to really switch this more from an interview-focused application to a more general-purpose social VR application. We feel there's a lot of potential for that outside of just the interview space, and there is definitely a lot of places that this application can go as far as in that field, because there isn't much currently in that space. Another one is more supported file formats. Right now, we really support the basic file formats for like images, videos, and then also objects. We would love to handle things like .wav files and similar file formats to that. And then also we'd like to be able to handle material files along with .objs, so then we'd be able to show more detailed OBJs and then textures with that. We'd also like to switch to the Mozilla supported networked A-frame. Mozilla recently picked up network A-frame from its original creator. We unfortunately didn't have time before the end of the semester to switch over to that, so that would be another thing that would be a good thing to switch over to in the future. But at the end of the day, the possibilities with this are endless. The field is pretty new still, and a lot of things are still being added, so there's a lot of possibilities and directions that this app can go towards.
Yeah, so with that, we welcome your questions, and thank you guys for listening to us. Question in the back? Yeah. You're talking about coordination at like a general level? So that was actually a major pain point for us. We have a lot of stuff that's persisted on the back end as well as the socket updates. So in the event of, there's a lot of complicated state here. So in the event of page reloads or maybe a user closing or reopening, we make sure to cache as much as possible so that even if the client's doing some work to catch up, it looks as though, nothing, there's no disrupt visible to the user. Does that kind of answer what you're asking? Okay. I think I saw George first.
Uploading large images and object files can take a lot of memory. Where is the deployment strategy with this looking? Is it something that like a RIT would host and then containing those files?
Yeah, so we're deploying static assets to Firebase hosting, which is just a wrapper for Google Cloud. The App Engine instance is where the images are being stored on a virtual machine. What's nice about the static assets is there's an admin portal, so if you want to ban users or whatever, that's great. At the moment, there is no admin portal for uploads, but it is well documented, like how to keep this kind of in check. And we also have a bit of checking in the user logic that has per user file size definition. So nobody can go too overboard, but it will require some level of oversight.
Well, I mean, we did our best to kind of separate a lot of different things out to make it a lot easier for a team to jump into and try and document what we're doing so that a team can jump in and then just be able to pick up from where we left off.
Yeah, and something the last team didn't have that we made sure to add was a version log. So they just said, use this technology but without versions, and it took us 2 weeks to get it up and running. So we've made sure to say, we can at least guarantee you that they work at these versions, and then after that it will be, a bit of a challenge. Other questions?
You said that Mozilla is picking up this framework.
Yeah, literally 2 weeks ago.
Yes, it just did.
Invested time on something that then do you have a sense of how difficult it will be to migrate? Is it just work?
I don't think it'll be too difficult to migrate. The API endpoints are there, they're defined. I think the biggest thing with the documentation was sparse and outdated. I mean, since it was a pre-alpha, that when we're trying to develop a network A-frame, resources that we find are using outdated API calls, and it was difficult to find any sort of support or help for that. So I think, we have all of the spots in our app highlighted that we're using network A-frame, so we were aware that that's a hot point, so that way we're able to migrate that, I think, pretty easily. I don't think that should be too much of a challenge.
Thank you.